Alright, the layout's been rebuilt and the block detects and the trackage now mimics my around the wall layout, so that way any programs that I write are going to be compatible with the around the wall layout. So right now we have a train on the side and on the throughway, and the extra one's just parked off to the side. I don't have yet the optical sensors for this side constructed, but they'll get there. One of the other changes I've made was now I've replaced the laptop computer with the desktop computer, and now the PLC controls have been able to move over here. So now I could have the throttle control in a more handy location. The thing about Lionel trains is they run in forward and reverse. The original programs that I've written earlier on, I locked the locomotives in forward to where they can only move forward and that's it. But that's not how these trains actually work. They actually do have the ability to move forward and reverse. They actually sequence forward, then neutral, then reverse, then neutral, then forward again, with each subsequent dropping of track power. Now, over the course of years, different locomotives act differently. These two that are sitting on the tracks now actually do act very differently. The steam engine in the back, the Lionel lines that's sitting on the side track, it turns out if the track power is off for more than, say, 10 or 15 seconds, the next time track power is applied, it's going to move forward again. The Delaware and Hudson RS3 that's sitting on the throughway will hold its cycle until, no matter how long the track power has been off. So unfortunately, this means there's no way for the PLC to maintain memory bits of the train's sequence, because some of them change by how long the track power is off. So I had to create a forward and reverse routine utilizing these optical sensors to actually sense the direction that the train is moving in. Earlier I just wrote a simple program, well, not simple, but it was just limited that it was just the train on the throughway, nothing else. But for the layout around the wall, I'm going to need 4 different areas where the trains can be stopped and changed motion. Right, of course, right here would be the throughway and the side track. This other area will be the spur, which needing forward and reverse is important because there's only one way for the train to back out onto the main line. And then once the train is on the main line, over in this area, there's going to be optical sensors for it to detect the forward and reverse motion. So once the train backs out of the spur, then the track power is going to be cycled to sense this train's motion so that it can move forward again. So for this program, so what I've actually done is I've made the forward reverse routine as a subroutine as ladder 7. And then I wrote this main program which will just allow me to, well, for now I can only select the throughway or the side track. So first thing we do is go into automatic mode so that the PLC has control of everything. And what I've done is, for the first part, I'm using this for the first cycle to say which train I want to move. This will be the train on the throughway. This will be the train on the side track. And then once that's been chosen, the soft alarm comes on for a second just to say, okay, choice is locked in. Now I have to tell it, do I want the train to move in forward or reverse? With the light off is forward, this is reverse, forward, reverse. So we're going to say the train on the side track, we want it to back out in reverse. So we start up, switches are immediately thrown. Okay, it was a little hard to catch everything in the video. So what we're going to do, again, automatic mode, select the train on the side track, lock it in. We want reverse direction, and then we're going to tell it to start up. Switches throw to the side. Wrong direction. Once the correct optical sensor is made, the sequence completes, and the train will continue to run until I tell it to stop otherwise. Now this time we're going to select the one on the throughway. So that would be when this light is out. And then we're going to want to make it go forward. Start up. You can see when the cab lights are on that track power has been applied. Now with this test track setup, there is a limitation that the throughway and the side track are actually very short. So it's actually quite possible for the train to overshoot and cause a problem. And that's also written into the program. So what we do is set, again, we're going to select the train on the throughway. Lock it in forward. Detected a problem.